What's up, guys? Let's get started here, shall we? Degrees and radians. Degrees and radians. If I say take your hands and open them 90 degrees, you know that's like 90. We all know that. What if I say 60 degrees? Okay, you got something like this, more or less. What if I say 30 degrees? Something like this, and so on. But what if I say take your hands and open them 7 pi over 5 radians? You'd be like, what? What's this guy talking about? We're not accustomed to radians. So now let me teach you how to convert from degrees to radians and vice versa. Converting ... degrees to radians. Here's what you do. If you want to go from degrees to radians, what you do is you multiply. You multiply by pi over 180. Pi over 180. If I give you an angle in radians and you want to turn it into degrees, what you do is you multiply by the reciprocal, 180 over pi. 180 over pi. So example, the goal here is to convert 60 degrees. Can you turn that into radians for me? Okay, here we go. So how do I go from 60 degrees into radians? You take 60 and you multiply it by, so look at your notes. The conversion factor we said was pi over 180. So you can type that into your Casio calculator. And if you do, it gives you a final answer of pi over 3. You can box that in, pi over 3. But what if you don't have one of those Casios? Here's what you can do. You can put a 1 under the 60. And then on your regular calculator or on Desmos, you can type in that green bubble. And it's going to say 1 over 3. And so then you can just copy and paste the pi up above, and it'll just be 1 pi over 3. The same answer as before, obviously. And that would be your final answer. Now, just a really quick comment, pencils down before we go to example B. You know how if it's 50 degrees, you say 50 and you put the degree symbol? What if it's radians? If it's pi over 3, technically, the equivalent to the degree symbol would be the abbreviation rad, short for radians. Am I going to be really picky about you attaching the label radians? No, I won't. If you just say pi over 3, that'd be okay. But if it is degrees, go ahead and put the little degree symbol because that doesn't take too much time. All right, pencils up. Example B. So negative 500 degrees. Here we go. So take negative 500 and multiply it by pi over 180 and do exactly the techniques that we mentioned in example A. And your final answer will be negative 25 pi over 9. Negative 25 pi over 9. Final answer. If it starts off negative, it's going to end negative after you convert it. All right, so we have 3 pi over 5. And then based on our notes, they say to multiply by 180 over pi. And here, what happens right away is the pi's cancel. Bye-bye, bye-bye. The pi's go away immediately. So all you're left with is all these numbers. So just type in on your calculator, you can type in 3/5 times 180 over 1, or just 180. It equals, and it'll become 108 degrees. 108 degrees. Now, how do we draw angles? Let's draw some angles here. So draw these angles in standard position. Draw an angle that measures 47 degrees. This is 0 degrees. Up here we have 90 degrees. That would be 180 degrees. And down here we have 270 degrees. Now, when we draw angles, there are two options. Either you draw the angle going up like that, or you draw the angle going down, okay? Now, you go up if the angle is positive. If you have an angle that is positive and you want to draw it, you start moving up. If the angle is negative, you start your drawing going downward. And whether it's positive or negative, you start it from this side over here, from the right-hand side on the x-axis, okay? So with that in mind, let's draw 47 degrees. That means 47 will be a little bit more than halfway, so maybe something like that. And then to draw the angle, what you do is you draw a bar. You draw, sometimes the textbooks draw it kind of dotted like that, like a dotted or a dashed bar, like a side. And that tells the reader that the angle's done. You've drawn your angle, you've cut it off at this bar, and here we go. That's about 47 degrees. So for example, B, let's draw 300 degrees. So you know you're going to have to go beyond 270 and about 30 degrees more, because that'll complete 300. And then go ahead and draw your dotted side like that there. And by the way, this terminal side, that's what the textbooks call it. Terminal side. Yeah, that's what the textbooks call your terminal side. Where the angle finishes, you draw that dotted bar. It's called the terminal side. And there we go, 300 degrees. Negative 1,000 degrees. Well, here it is negative, so we're going to have to start drawing downways, okay? Now it's 1,000. It's 1,000. So look, if I go around the world one time, that's 360. If I continue and go around the world again, and let me stop right there, that's 2 spins. That's another 360. 360 plus 360 is 720. But I need to go to 1,000. So I need, on a calculator, I think I need 280 more, because that'll give me 1,000. So far we have 2 360s, that's 720. Draw 280 more. So 280, so let's see, so that's 90 more. That's 180 more. That's 270 more. So I need 280, so 10. Draw 10 degrees here. That's like a little baby. That's like a little baby angle right there. And so that would be, and then draw your terminal side. And there we go. That's 1,000 degrees in the negative direction because we went downwards. 11 pi over 4 radians. How in the world are we going to draw radians? Well, turn radians into degrees and then just draw the degrees. It's the same thing. So do what you did earlier. Convert it is what I'm saying. 495 degrees. So let's draw positive 495 degrees. So 495 is beyond a 360. So that's a 360. Now, how am I going to reach 495? It's 360 plus 135. Does that create the 4? Yeah, that creates 495. So you've already drawn a 360. So draw 135 more. So 135 would be like, maybe like right there, more or less. 135 extra degrees. Terminal side. Then state the measure of angle theta, period. State the measure of angle theta, period. You're given a picture, and the picture looks like this. It looks like that, it looks like this, boom. And then they give you the terminal side, like that. And then in a third color, they say that this extra bit is 22 degrees. And to make it clear, that green spiral, that is theta. You tell me what that green spiral measures. I always tell students to trace the spiral piece by piece. Watch. If I trace it here in red, so far, if I stop there, look, so far I have traced, so far in the bag, that's 360 that I traced. Now, what if I keep tracing, boom, boom, like that? You see that extra that I threw in? That is a bonus 90. I've thrown in an extra 90. The only thing left to trace is right here. See that? Look, how much is that little pocket? Well, you do know that in every corner you have 90 degrees of containment, 90. So right here, this portion is 22. So how much does this little extra have to be to complete 90? We'll just subtract. Go 90 minus 22. That's a 68. So that extra 60, it's not drawn to scale, by the way. That extra 68, that's what you add on top of these guys. You add those up, and that'll be your final answer. So 518 degrees, box that in, and it's positive, right? 518 degrees is our final answer. Let's see. So We're going to begin here and let's go around the world right there. So far, that spiral is a 360. I know the answer is going to be negative because I drew down. We'll get there. First, let's just measure the size of this thing. So far, I've traced the 360. If I go around the world again, like that, that is a bonus 360. So that's another 360 on top of that. So all that's left is this extra snippet here. So do what you did earlier. Take the 37 away from 90, and that'll give you back 53 degrees. So let's add a 53 on top of those guys and make it negative, and we're done. Negative 773 degrees. A fact that you hopefully recall.
Your quadrants. Do you guys remember which quadrants are which? The quadrants. This is quadrant 1, this is quadrant 2, this is quadrant 3,
and this is quadrant number 4. So if I give you an angle and I say, hey, which quadrant does this angle terminate in? You got to be able to tell me. All right, so let's begin with example A. So we'll go A and B. If I were to draw this thing, in which quadrant does it terminate? Let's find out. Okay, that's 360. And 360 to 500, I need an extra 140. So like right there, more or less, something like that. So that's 500 degrees. And it terminates in quadrant. That's quadrant 2. So my final answer would just be Q2, quadrant 2. This guy terminates in quadrant number 2. Well, if I were to draw negative 800, let's see, negative 360, and then another spin is negative 720. So I need 80 more, like right there. That would be like negative 800 degrees. So clearly that terminates in quadrant 1, 2, 3. Yeah, it's 4. So in quadrant 4, this thing terminates in quadrant 4. What if it's 1,000,000 degrees? The long way would be to draw 1,000,000 degrees. So 360, 360, 360. You would be doing this like all day, right? And you'd probably lose track. I know I would. I'm going to have to go around the world, I don't know how many times until I draw 1,000,000 degrees. And then it either ends at 1, 2, 3, 4. There's got to be a faster way. There's got to be a faster way to see which quadrant 1,000,000 degrees terminates in. There is a faster way, and we will cover that in class first thing Monday morning. Oh.